So this is question 10 from the Chapter 8 homework, and this is letter A. And so I'll use this as an opportunity to go through one example so you can see what the question is asking for and how you would think about it. So the question tells us that this is a double displacement reaction and that the reactants are all an aqueous solution, which means when we write the formula, we're going to write AQ. Now, double displacement reactions are a switching of the partners in ionic compounds. And so these are both ionic compounds, and the first part is a cation and the second part is an anion. And so that would be true for both. That's true in ionic compounds. And so if they were to switch, ammonium would go with nitrate and barium would go with phosphate. So the first part of the question wants you to name the products. Well, the wonderful thing about ionic compounds is how you name them is simply by naming the two parts, the cation and the anion. So to figure out the names of the products, all we have to do is switch the names. So the products would be ammonium nitrate, because it's gonna switch these two. And then in the homework they want you just to separate it with a comma, so you just put comma, and then barium phosphate, and you don't have to put a space after the comma. And so the first part of these questions just wants you to switch, wants you to name the products, but in ionic compounds we can switch the names. Okay, so that's the first part. And then the second part wants you to write the formula equation. And some of you may like to write the formula equation first and then name the products. I know in one of the questions after this one of the products is water, and so you'll have to be sure to name it as water. Just think about that kind of thing. All right, so let's write the formulas. Now, before I like to write the formulas, if I were doing this, I'd like to write the ions. And so if I'm looking at my reactants, I have ammonium, which is NH4 plus, and phosphate, which is PO4, 3 minus. And then I have together barium, which is Ba2 plus, and nitrate, which is NO3 minus. If you're having trouble with your polyatomic ions, this was covered in chapter 6, and so you might want to go back and brush up on it, or it's a good reference so you can refer back to it. So now if I want to write the formula of the reactants, ammonium and phosphate, since phosphate has a 3 negative charge, it's going to take 3 ammoniums. And then ammonium has a 1 plus charge, so it only takes 1 phosphate. So there's one reactant. And then it's going to react with barium nitrate, and nitrate has a 1, so there's 1 barium. And barium has a 2, so there's 2 nitrates. And the problem again told me that all of my reactants were aqueous. And now I need to switch the partners. And so I know that my ammonium is going to go with the nitrate, because that would be a new plus minus partner. And the barium will go with the phosphate. And it's always the 2 outside reactants will go together and the 2 inside reactants. Now, before I go and just write what's going to happen, I like to check the solubility chart to see if anything is going to form a solid. And so if I check ammonium with nitrate, I see that that is aqueous. So really nothing's happening with ammonium and nitrate. ionic compounds that are aqueous will remain dissociated in solution. So ammonium and nitrate are just floating around. And then barium and phosphate. And here's a little pet peeve of mine. In your solubility chart in the textbook, there is no phosphate. So you wouldn't be able to check. But this is a homework, so you could just Google solubility table or solubility chart, look at images, and find one that does have barium and phosphate. And if you did, you would see they would be insoluble or they would form a solid. That's what insoluble means. And so just to give you a visual, ammonium phosphate would be a liquid and barium nitrate would be a liquid. I think they're both clear and colorless. Then you would put them together and instantaneously in the liquid a white powdery solid would form, and that solid would be the barium with the phosphate. So once I've determined a reaction is going to happen, and I know that because a solid is forming, I'm going to write these products together. So ammonium and nitrate both have a plus charge. So it'd be NH4NO3, a 1 charge, not a plus. And I already saw on the solubility chart their AQ. And then barium, let's see, if phosphate has a 3, it would take 3 bariums. And barium has a 2, so it's going to take 2 phosphates. And then I would want to put an S there. Now that is the equation with the formulas, but it's not balanced. So I'm going to go to the next slide so we can balance it. So let me rewrite it, and I've got to remember, oh, sorry, I'm too close to the button that makes it go back and forth between the slides. So I had my reactants, which were given to me. And then I made my products by switching their partners. That's what double displacement, a big switch. And then barium phosphate. And so now I need to balance it. And if it were myself, when I balanced it, I would balance the polyatomic ions instead of breaking everybody down. It will be so much harder if you break everybody down. But since the polyatomic ions stay together in the reactants and products, you can balance them. So let's try it that way, because I think as you get better at balancing, you can figure this out. So barium is one thing. I like to do my metals first, and then I'll just go in order that I see them from left to right. So I'll balance the ammonium. I'll balance the phosphate, and then I'll balance the nitrate. And the polyatomic ions, I just started on the left and wrote them from left to right. So the order truly in balancing is not ultimately important. So let's balance. So I see here there's 1 barium, but on this side there's 3. So I have to put a coefficient of 3 in front of the barium. All right. And then here's ammonium, and I see there's a parentheses with a 3. So there's 3 ammoniums. And this side there's no parentheses, so I know that means there's 1. So I would put a 3 there, coefficient. And then phosphate. So here's my phosphate, and I see that there's just 1. There's no parentheses. And on this side, it's hard to see, but that's a 2. So now, to get the phosphate, I have to put a coefficient in front of this whole formula there, because you can't change the formula or put it in between. So I put it in front of that formula, and that gives the the phosphate 2, but then it changes the ammonium that I already did. So I see that there's 3, but I have to say 3 times 2. So now on this side, there's 6. So when I come back to the product side, there's still only 1. So I'm going to take my eraser, and I'm going to erase that. And let me write back in my things that I erased that I didn't want to. There we go. And I'm going to replace the 3 with a 6. So now there would be 6 of those. Okay, so far so good. And now I haven't done nitrates, and here's the nitrates. I see there's 2 of them in the formula, but I already wrote a 3, so 3 times 2 is 6. And over here I see there's only 1 in the formula, and so 6 times 1 is 6. So that's balanced. So then what your homework problem wants you to write is that balanced equation. So we would say 2NH4 3 4AQ plus 3BaNO3 2AQ arrow 6NH4NO3 AQ plus, there was no coefficient in the barium phosphate, so Ba3 PO4 2, and don't forget the S. And so this last equation is what would go into the second box. A couple observations, and the products, the barium phosphate could be written first and the 6-ammonium nitrate second. It wouldn't matter. The other things, if you look at this, there's a lot of room for error. So if you type it in and you get it wrong, check it and see, make sure all your O's are capitals and all your subscripts are subscripts, and you have parentheses where you're supposed to and don't have parentheses where you're not supposed to. And if you try to correct it and it's still wrong, please reach out to me. Let me try to see if I can find the mistake. I would hate for you to use all 5 attempts on trying to get the right answer. Now remember, if you want to try to complete all the problems before you say check my work, because otherwise it will mark all the other ones wrong and you won't have a chance to do that. So you could have more questions. There's lots of these problems, but it's good practice. Just try to think it through, and I'll be happy to help if you have another question.